All right, welcome back. We're going to do 12.2, and this is multiple integration. More general boundaries. Okay, so not all our boundaries are going to be rectangular in nature. Okay, so even something like, let's take the integral 0 to 6. And now here we're going to put 0 to square root of y, 6x y squared dx dy. Okay? So we just want to understand what's going on here. So what we are doing, we are integrating z equals 6x y squared, okay, in a region of space that looks like so. Okay, now we're going to do this. This is x. This is y. Okay. Now, here, what we're going to keep in mind is that since this and dx is in the inside, that means x goes from 0 to square root of y. So x equals the square root of y. Okay, and we can take here, we can take that y is greater than 0, okay, because it's between 0 and 6. That's equivalent to x, started crossing it off like a moron. Y equals x squared. And that works because y is greater than or equal to 0. Okay? So, our region, if we map it, 1, 2, 3, 4, 5, 6. Okay? And it's actually going to be the region above the graph. Okay? How do we know that? Okay, first, y goes from 0 to 6. 0 to 6. X goes from 0 to square root of y. So x equaling 0 is this line. X equaling the square root of y is this line. Okay? We could also set up the integral. Sorry about that. We could also set up the integral from 0 to square root of 6, x squared to 6, 6x y squared, now dy dx. This should be the same integral. Because we're just setting it up in a different way. Okay? But let's go to the original. So let's take the integral from 0 to 6, 0 to square root of y. Oh, let's erase that, because we're just going to go straight here. Let's just do the integral in in x first. Okay? So we're going to get 6 x squared over 2 y squared. X goes from 0 to square root of y dy. Now, we're going to go ahead and plug x equals 0 and square root of y in. So that means we're going to get the integral from 0 to 6. Let's put a 3 in front for the 6 divided by 2. Let me rewrite that. So 3 for the 6 divided by 2. The integral from 0 to 6. Now remember, x squared, so if you plug in square root of y, you're going to get y times y squared dy. Okay? So now we're going to get 3 integral from 0 to 6 y cubed. Okay? Which is just going to be 3y to the 4th over 4 from 0 to 6. Okay, let's go ahead and plug those numbers in. 3/4 times 6 to the 4th equals, I need to get my calculator out. $972. Okay, so if you go ahead and you do this integral, you should also get 972. What the heck? Let's do it. Moved more than I wanted to. Okay, so if we do this integral, we're going to get the integral from 0 to square root of 6. Now here, we're going to do the integral in y first. Okay, so doing the integral in y first, we're going to get 6x y cubed over 3. Y goes from x squared to 6. We're going to do dx. Okay? Let me actually give myself a little more space here. Just let me... There we go. Okay, so the 6 and the 3 cancel. So we're going to get 2, the integral from 0 to square root of 6. Now remember, y cubed is going to go from 6 to x squared. So we're going to have x times 6 cubed minus x squared to the 3rd is x to the 6th dx. Okay. 6 cubed is 216. So we're going to have 2 times 0 to square root of 6, 216x minus x to the 7th dx. That is 2 times 216 x squared over 2 minus x to the 8th over 8 from 0 to square root of 6. Should not have done this problem. 2 times 216 times 6 over 2 minus square root of 6 to the 8th over 8. Let me do that in my calculator. So 216 times 6 minus 2 times, amazingly, that came out to a whole number. And that does actually come out to 972. All right, be back in a minute with the next video.